Hey everyone, welcome back. So normally what we would do in this week of the course is we would go to the Immersive Learning Laboratory, which is a tutorial room which has virtual reality, Oculus Rift virtual reality headsets for everybody to use. And this is really important because, as Chris Milk, who's a virtual reality booster, has said, talking about virtual reality is like dancing about architecture. There's just something you have to feel when you use virtual reality. So I'm really sorry that you're going to miss out on that opportunity, but I hope that many of you will have experienced VR. But I'm going to run you through some of the key concepts and then set you up with an independent learning activity which you can follow on Canvas to go and look at some examples of virtual reality film, virtual reality games and some other applications so that you can see what maybe is involved with virtual reality and what those experiences might be like. I really encourage you to read people's reviews of virtual reality experiences, just to kind of understand what the perspective of someone in VR is like. So one of the main concepts for understanding virtual reality and the difference between a device like Google Cardboard and the Oculus Quest is this idea of 6 degrees of freedom, which I'm going to model for you with my head. So the first is yaw on the y-axis, which is the ability to turn left and right. But also we have the y-axis up and down. We can pitch our head forward and back, left and right. But we can also roll side and forward and back. So these 6 degrees of freedom are necessary for being able to have a virtual display that allows us to move around an environment so that our head can be tracked and the display modified based on these different degrees of movement that we have in our head. Now some devices are only 3 DOF devices, 3 degrees of freedom. If we look at something like the Oculus Quest, all it allows me to do is look up and down, left and right. But it doesn't do anything if I move forward and back, which is hilarious when someone is in a horror game and they move their head back away from it because it does nothing. This device has no idea where it is in the world, it only knows its rotation.
Oculus Insight is our revolutionary VR system that uses computer vision algorithms to enable real-time room mapping and positional tracking on the Oculus Quest and Rift S headsets. Oculus Insight uses an approach called visual inertial slam to track the position of your head and constellation tracking to track your hands. Together, these technologies precisely translate your movements into VR, so you feel truly present in the virtual experience. Oculus Insight relies on 3 types of sensor data. Image data from cameras in the headset to generate a 3D map of the room, pinpointing landmarks, such as corners of furniture and patterns on your floor. Rotational velocity and linear acceleration data from the inertial measurement units in the headset and controllers track your head and hand movements. And infrared LEDs in the controllers are detected by the headset cameras, further improving Insight's ability to track the position of the controllers. As you move through your space, Insight detects unique image features in the room and triangulates those points in 3D, using up to 30 views per second. Oculus Insight uses a breakthrough approach for multi-sensor, nonlinear optimization to fuse all of this data in real time, updating its position measurements every millisecond. But to be fully immersive, our tracking system also had to eliminate even minute delays and discrepancies between your physical movements and equivalent motion within VR. To help sync up these movements, we use a kinematic prediction algorithm that's been developed and tested through thousands of real user trials and can effectively predict exactly where the user is going to move in the milliseconds ahead. Our industry-leading expertise in computer vision and innovative use of visual inertial slam and constellation tracking delivered a system able to track your position and environment in real time with sub-millimeter precision, creating an experience effectively free of lag, jitter, and other VR-related discomfort. We also tuned the entire algorithm pipeline to optimize Insight for power consumption, enabling up to 3 hours of wireless use on Oculus Quest's internal battery. Oculus Insight demonstrates that you can reduce power and compute overhead in an on-device, real-time tracking system, while also dramatically boosting precision. It's the first of its kind in VR, and a glimpse of the increasingly untethered and immersive experiences still to come.
Another key concept that might help you understand what different virtual reality devices are is standalone versus tethered. Now, a virtual reality like this, like the Oculus Go or the Oculus Quest, is standalone. It doesn't need an external computer to run. But the first generation of VR devices and more powerful devices to run really high-end games like Half-Life Alyx require an external computer to run, because the hardware that's necessary to power that game is bigger than what can be condensed into your head and has a lot more energy demands. So you end up with this situation where you're tangled in cords while you're playing. But also that it really increases the cost, because you're going from having to spend several $100s on a virtual reality headset to needing a $1,000, $2,000 computer to play them on. Another idea that can be really useful for you in your assignments is the difference between room scale and seated virtual reality. A room scale virtual reality is one that might be 4 meters by 4 meters, that you can walk around, crawl, jump, duck, weave. There's a great boxing game that I like to play on my Oculus Quest. But seated VR is when you're sitting on a chair and you don't need to move around. You can use the controllers to walk around the environment that you're in. And it might seem really obvious to you that room scale is better. But I want you to look around your home and tell me, do you have any 4 meter by 4 meter squares in your house that don't have furniture in? If I want to play Thrill of the Fight, that boxing game, I've got to push my sofas up against the wall and remove the coffee table from the room to be able to play. As a result, I don't play it that often. Seated experiences are also better for longer experiences. They allow you to play for standing and moving and constantly is exhausting. And although great for a fitness app, isn't great for long experiences of play. And you might also want to think about inclusion and who you're excluding from an activity when you design it for standing room scale. Older people and people with disabilities who might not be as mobile. And we'll talk about that next week. Another concept that you might want to get your head around in your independent learning is the difference between stereoscopic and monoscopic. A virtual reality headset has two separate displays. So this is a stereoscopic headset, because each eye can get a slightly different version of the image. The result is depth perception and a greater sense of presence. Monoscopic is like being in a cave with an image wrapped around you, but stereoscopic is like you're standing there yourself. So what I want you to do now is, below this video on Canvas, you're going to find some links to VR applications that showcase the best variety, I think what are the best examples of VR right now, but also kind of the breadth of what is currently out there in VR film, in VR gaming, and in other VR applications like Google Earth VR and Google Tilt Brush. And this is going to help you get an overview of what's already out there, so that when you come to the tutorials that you're equipped to talk about VR, and when you develop your assignment, you're going to be able to base your idea off of other great ideas. No copying anything that's already out there, but at the very least, I want to see it in that this will help you inform what's possible and where there is potential. Cool. And if you have any further questions about the virtual reality assignment, make sure to ask your tutor in the week 6 and week 7 tutorials, or post them on your post them on your tutorial discussion boards. Thanks very much. I'm Marcus Carter, and I'll see you in the next lecture.